So this is 23.4 here, and so is this angle. And so this would be the right angle, just like this is the right angle. If you study geometry, you understand that this is similar triangles. So to find this would be like the base of the triangle. If we know this is 23.4, then the opposite would be this, and the adjacent would be that, because this is the hypotenuse. And we now know that 149.94 is the hypotenuse. So if we use TOA is the memory trick. So it's sine, cosine, tangent. Each of these gives you different things. Since we know what the hypotenuse is and we're trying to find the adjacent, let's use this, adjacent and hypotenuse. So you do the cosine of that angle. So it's cosine of 23.4 is equal to, cosine is equal to adjacent, so that would be g sub y, because we're pretending that this is the y-axis and this is the x. So g sub y over hypotenuse, which is 149.94. All right, so this equation should look a lot like that. I'm basically using that as my guide. And if you know your algebra, you can just pick this up and put it over here. So you say 149.94 newtons times whatever the cosine of 23. So cosine of 23.4 is a decimal, and that gets multiplied times that. So times 149.94 equals g sub y is equal to 137.6 newtons. So there, now we know what this is. Let me erase the g sub y and I'll write the actual number. 137.6 newtons. Let me put a polygon around this. And now we need to find g sub x. So maybe I'll do that over here. And hopefully my students will leave me alone so I can do this without breaking the video that I'm making. So lo and behold, if you use one of these as cosine, the other one is inevitably going to be sine. We could use tangent too, because now we know what the adjacent is. We could use tangent of 23, and then this would give us opposite and adjacent. We know the adjacent, but I'm going to just use sine. So sine of 23.4 is equal to opposite over hypotenuse. Opposite happens to be g sub x, because that's in the x direction. So g sub x over hypotenuse is 149, just like it was before. And so we can just pick this up and move it up there. And the way that would look would be 149.94 newtons times the sine of 23.4 equals g sub x. So let's multiply that out. That's sine of 23.4, that's a decimal, times 149. 149.94 equals 59.548, whatever. We can stop at some point counting the decimal places. So that gives us now the solution for g sub x. I'll make a crazy looking polygon to outline that. Then step 4 is to find the friction. Static friction is less than or equal to mu times n. N is normal force, and normal force has to be this. So the ramp has to support up to this amount. So it's going to be an arrow that's equal to and opposite to that. So F sub S less than or equal to mu is 0.53, and then 137.6 newtons. So we multiply that. So the force of static friction is 72.9 newtons, and that is your solution. So, will the block slide? Will the block slide? Question. All right, so force of friction will support up to that, and we found out that G sub X was 59. So 59 in this direction, 59.54 in that direction, but the force of friction can withstand up to 72.9. That's not as big as that. So no, friction will win. And that's how you do it. This is how you solve this. If you're one of my advanced students, I want you to work it out just like this, use it as a model, and then try another problem where you change the mass, change the angle, change the mu value. Remember, this needs to be less than 90, somewhere in between 0 and 90. And this needs to be something between 0 and 1. And then, of course, the mass, you can just pick whatever you want and go from there. What I suggest is that if you have like a partner working with you, have them work out the same thing, but don't look at each other's work unless you are in the early stages of development where you're still not sure how you're doing it. Maybe check each other's work after each phase, and then gradually you can work all 4 steps out and then check your work. And hopefully if you both come up with the same information, it should give you confidence that you're doing it right. Good luck.